Good morning. Today we are going to start the new content, that is uniform convergence, based on the sequence and series of functions. The definition for the limit function. Suppose fn is a sequence of functions defined on E. So this is your fn, and suppose f1 is defined on E, and f2 is defining on E, f3 so on. There are so many functions which are defined on E, the sequence of these functions, and suppose the sequence of numbers f and x converges to fx. Now what is the difference between fn and fnx? Fn is a function, fine, and fnx means the value of the function. Right? The value of the function fn at x, right? So I call this as a number also. So these are the numbers which are converging to fx, right? So for the sequence fn, which is defined on the set E, and suppose these are the sequence of numbers f1x, f2x, f3x, so on up to fnx. That is, if f1 is defined on E, then the value of the f1 at x, where x is belonging to E, right? So if f2 is defined on D, then I'm having the number as f2 at x, the value of the function f2 at x. Similarly f3x, so on up to fnx. So if all these numbers converges to fx, so if all these numbers are converging to f of x for every x belonging to E, now here n is tending to infinity. That is, there may be infinitely many functions that are defined on E, right? So for that infinitely many functions, if I'm having the numbers f1x, f2x up to so on infinitely many, then we can define a function f by f of x is equal to limit n tends to infinity on fnx. Please mark this as 1, where x is belonging to the set E. So under these circumstances, we say that fn converges to f on E, right? Then this f is called limit or limit function of fn. So fn converges to f on E. We can also sometimes say that fn converges to f pointwise on E, right? If this one holds. So fn converges to f on E. We can also say sometimes that fn converges to f pointwise on E. So it is one and the same thing. So we can also write that fn converges to f pointwise on E. As it is for every x belonging to E, right? Similarly, we can work on the sum of the series. So here if summation fnx, where n goes from 1 to infinity, this converges for every x belonging to E. So if it converges for every x belonging to E, and if we define f of x to be equal to summation fnx, where n goes from 1 to infinity, where x belongs to E, please mark this as 2, then we say that function f is called the sum of the series. summation fn n going from 1 to infinity. Right? So this first result is for the limit function and the second result is for the sum of the series. Right? Alright. What if fn is continuous, differentiable, integrable? Then what about the summation fn n going from 1 to infinity, the sum of the series? Is the sum of the series also continuous, differentiable or integrable? That cannot be in general continuous, differentiable or integrable. Right? But under certain conditions, the sum of the series can be continuous, differentiable, and integrable or integrable. That we will see in the next contents. Alright, thank you.